Hi, our team is formed by Sofia, Caro, and Carla. We are going to explain the unit circle and how it works. First, we need to know all the values of the unit circles. They are 0, 6 pi, 4 pi, 3 pi, and half pi. Remember that when we work with the unit circle, we need to use radians in our calculator. Also remembering that 2 radians are 360 degrees. 1 half pi has 90 degrees. 1 pi is 180 degrees. 1.5 pi has 270 degrees. And as I said at first, 2 pi are 2 radians and the coordinates of the terminal points 1, 0 when pi is equal to 0. Root square of 3 over 2, 1 half when it is a sixth of pi. Root square of 2 over 2, root square of 2 over 2 when it is a quart of pi. 1 half, root square of 3 over 2 when it is a third part of pi. 0, 1 when the value of pi is in 1 half. So when we have a Cartesian plane, as we can see, this is going to be your x and this is going to be your y. And when you are moving in the places where it finishes, we obtain the coordinates. Here we have a table where we explain how to get the value of sine and cosine. In the unit circle, the cosine is equivalent to x in coordinates and the sine is equivalent to y. That is why we have the same options in the circle and the coordinates are exactly the same where it was x and y. If we draw the circle, we can obtain the coordinates from sine and cosine. To determine the value of the corresponding trigonometric functions on a unit circle that it is smaller than 2 pi, we need to consider that the line that we have is x and the other line that we have here is y. What we need to do is to locate the 4 quadrants of the circle and see where is x and y and check if they are positive, so you can determine if the coordinate is between 0 and 1 half. If we have from 1 to 3/4 of pi, both will be negative. While we have 3/4 of 2, we will have a positive x. Once you have determined the values of the coordinates, you can know if x will be positive or negative. At last, we need to know that the first 3 trigonometric ratios, sine, cos, and tangent, have a relation with the cotangent, secant, and cosecant. Because the tangent is equal to sine over cos, the cotangent will be cos over sine, as we can see. Cos is equal to x, and it is related to the secant, that is 1 over x or 1 over cos. Sine is equal to y, and it is related to the cosecant, that is 1 over y or 1 over sine. With this, we know all the elements to calculate it are radian less of 1 pi, with all its trigonometric ratios.
Here we weren't allowed to use our app because there were too many operations. So I'm gonna explain you right now how to use this table, you have to look at the denominator of the fraction in the first row, and then you're gonna have to look at the value of your rate or your ratio. Like in this one is minus 5 over 6 pi, which you can use a rule of 3 where you can convert the values in degrees, and you got minus 150, and you have to look forward the circle. So here I'm minus 180, so it's in the third sector because the sectors never change no matter in which if it is positive or negative, it never change. So then when you know the exactly value, here you're gonna the x and y in negative, the both. So we're gonna look at the denominator of our radian, and we go to the table and we look that the cosine and the sine are these ones. So the cosine is minus root square of 3 over 2, and sine is minus a half. Then the tangent is equal to sine over cos. So we got root square of 3 over 3, and the cotangent is like when we use 1 over tangent. So we just need to do 1 over root square of 3 over 3, and we got root square of 3. Then we got our second, that is the opposite to the cosine, so you have to do 1 over cos, which means 1 over root square of 3 over 2, and this is what you have. And then in the cosecant, which means the opposite of the sine, you have to have 1 over sine, and you have to look 1 over minus half, and you get minus 2. So here for our final problem, we have like 13 over 3 pi, which means there are more than one loop because 2 pi is equal to one loop. So I like to use the rule of 3, and you know where you have to convert in degrees, and then you know how much loops you have to do. So here we're gonna do the sector that we have in our radians are the first sector. So we have both positive. So we just need to check our denominator and go to our table. So we have to know that the cosine of our ratio is a half, the sine is root square of 3 over 2, and the tangent is sine over cos, which where you get the root square of 3. The cotangent is 1 over root square of 3, so you get this value, and also with the other two. So this is gonna be all for us, and thank you very much.